Hi everyone. We are live with Preeti in the next session, and she's going to be talking about data security best practices in multi-cloud. I would give it to her to talk about her profile. So I am very fascinated about what she has done so far, and like, so I would want her to speak more. Over to you, Preeti.
Okay. Thanks a lot, Vandana. First of all, I'm glad that I'm part of this InfoSec session. Thanks a lot for reaching out to me. So let me quickly share my screen. Okay. Is that shared? Can you see that? No?
No, not yet. There is a share button at the bottom, the green color.
Yeah, I did that. Now?
Yes, now I can see it. If you can make it like a presenter mode, then it'll be more highlighted.
Yeah. Is it okay?
Yes, Preeti, I can see that. Yes.
Okay. So first of all, I think everybody who is attending this session today, all the participants, I hope everybody is healthy and safe considering our current situation. Now, this is a very fascinating topic because all of us in InfoSec, in some way or other, are handling data. So I thought, with the new dimension of the emerging technologies, everybody getting into the clouds and dimensions getting more complex with multi-cloud, what should be the best practices? So I would try my best to cover within the time slot that we have into this. So most important thing is this disclaimer that you see on the bottom of the screen. All the views that I am representing in this session are totally based on my knowledge and my personal research, and it does not represent anything, any view or any data from my organization, that is IBM. So with this, I will quickly start. So I will walk you through this brief agenda. We will go structurally through data security aspects, challenges, and what are the likely ways of considering a data-centric model. Then we'll talk about data encryption standards, data security considerations for multi-cloud, and finally, we'll touch upon what are the best practices that we can utilize in multi-cloud environment. So with this, a quick introduction of myself. Who am I? I am an Indian Army veteran from the elite corps of signals. I have done a short service stint of 5 years. I am Ahmedabad alumni of 2009 and 10 batch. I am a managing consultant and solution architect from IBM Security. I have been associated with IBM from 2012 onwards. As well as, I love community work. So with my day job, I love to work. We have a Women in Security Excelling chapter for Bangalore. I'm leading the Bangalore chapter and also leading the India chapter for external events. So I hope everybody understands the collaboration of the power of collaboration of community. And InfoSec Girl community is one that I have been, looking for through Vandana. She is a great personality, and she is also part of WISE IBM. That's how we know, and we thought it's a good idea to collaborate in this community. So I'm glad I'm part of InfoSec Girls community with this session. Now, moving on. So let's start with understanding the aspects of data security. So as you see here, so there are 3 planes that we can view data security into. First of all, to start with, what are the data types? So it majorly falls under 3 categories. We have structured data, we have semi-structured data, and we have unstructured data. So all of us know the differences. I'll talk about a little bit more in detail in upcoming slides. Then, in addition to this, we do have data protection. So when we have to think about data security, we should understand where we want to secure the data. So the aspects in terms of protection, we see data can be at rest, data can be in use, or data can be in transit. So these are the key protection aspects. Now, the complexity and dimension further increases with the cloud environment. So we know the basics of what is a hybrid cloud. So we have various deployment models of SaaS, infrastructure as a service, and platform as a service. Now the complexity increases with multi-cloud. So I'll also touch upon those aspects in my next slide. So with this, I move on, and let's deep dive a little more into what is the difference between structured, semi-structured, and unstructured data. So what you see here, structured data is nothing but it's highly organized nature of data, which can be displayed in rows, columns, and relational database. So there is a relationship that we can maintain among these data, easy to search, easy to query. So it's highly structured nature of data. So, for example, we have numbers, dates, and strings. And whereas if you see on the semi-structured side, this is relatively structured because we can establish some relationship, but it's not organized in rows and columns and records. Examples are JSON, XML, or .csv nature of files. So now Gartner has estimated that this is going to be 20% of any enterprise or organization data, that is structured data. Whereas unstructured data on the other side is going to be 80%. So all of us know about the Moore's law, with which the processing technology is exponentially expanding. It is giving us that space, or the way we can have more and more data storage possible. So with that, the unstructured data is just shooting up with the emerging technologies. These cannot be displayed in rows and columns how we can do in structured, or there are no sort of relationships that we can establish in semi-structured data. The examples would be images, audio, video, files. Sometimes you have embedded files like spreadsheets, PDFs in your emails. So this is highly unstructured nature of data. And if this is going to be 80% of any organization or enterprise thing, it's the time that we should start pondering on how do we protect it. Now, structured data requires less storage, whereas unstructured data requires more storage. And it is difficult to manage and protect with the legacy solutions that we have. Now, little bit more on the aspect. So I think most of you would have seen this. I've taken this directly from the CCSK guide version 4. This is from NIST, the model they have provided for cloud. So what you see at the middle is the service model. So we have 3 service models: software as a service, platform as a service, and infrastructure as a service. Now, when you go to the deployment model, so we have public, private, hybrid, and community. Now, how the complexity, degree of complexity increases is, this is going to be in any cloud that you use. Now, the organization goes with a cost benefit analysis. So they don't want vendor lock-in. So they use AWS, they use Azure, they use Google Cloud, IBM Cloud. So you name it and it's there. Within that, you may have public, you may have hybrid, you may have a private. So the complexity is further increasing there. That's the important thing that we need to understand, how it is varying with multi-cloud. Hybrid is fine. It can be a combination of public and private and community. Now multi becomes a hybrid cloud of AWS or public cloud of Azure or private cloud of Google. So there is the difference in the complexity here. So these are the key aspects of data security that we have to keep in mind when we start deep diving into how do we want to secure our data. Moving on. Now let's have a quick view of what are the challenges of securing data. Because today, if you see, this is constantly increasing and in scope as well as in difficulty. It is dynamically growing. So we just spoke about the Moore's law. With the technology processing increase, it's dynamically growing. Now, data is highly distributed here now. With the cloud stuff, we can store anywhere in any of the data centers that are available across the globe. So it becomes further, the boundaries are kind of dissolving here. So earlier, if you see from the traditional model, we were sure that here is my perimeter and here my data is going to reside. But with the cloud, if you go on using Azure, you don't know where their data centers. If you go on AWS, you don't know. I mean, the boundaries are expanding and it's highly dissolving. Now, the degree of complexity is increasing as we just talk about it because there are multiple vendors, CSP cloud service providers, so enterprise going with that. And on top of it, we do have regulatory and compliance implications that we need to keep in mind when we have to think in terms of securing data in multi-cloud environment. So on the right-hand side view that you see, it gives us, a shared security model. So now, data security is not only the responsibility of enterprise and organization, it is going beyond that. And how? So what you see here, the ones that are highlighted in pink are only the customer responsibility, and gray ones are the cloud service providers responsibility. So with the deployment model, if you see, if you're using only the infrastructure service, then it's like 60-40% distribution of responsibility between customer and the provider. If you see a platform, data and application, it's like 20-80%. And if you see the software as a service, it's like 10-90%. All said and done, in all the three models, what you see is data is always customer's responsibility. So it's more important because of this complexity here in multi-cloud. We need to understand the traditional ways are not going to help us secure our data. What is that we need to do? So data is at the core, at the center here, and end of the day, enterprise and organizations' responsibility to secure. So there is the need of a data-centric security model to think about how do we secure, because data is customer responsibility. So how the customer will think about securing it? So first of all, we should know as an enterprise and organization, what is that we want to secure. So we should know the data, where all it is, especially in the spread of different cloud models and different cloud providers. Where is your data residing in terms of the geographies, so that you know what geography your data is there. If there are laws around data transfer from one geography to another, we need to keep in mind. Then how to protect critical data. This is the technical aspect. So once we understand, get the visibility that, okay, this is what I want to secure, because we cannot secure everything. So we need to know what are crown jewels in terms of what is critical data for my organization and what is non-critical data. Because if you want to secure, it costs based on the protection technology that you want to use. So that is how do you want to protect your critical data? Then who should access your data? Now, once you have understanding, visibility of what is your critical data, what is your non-critical data, where is it residing, and what is the technical technology you're using to protect it, you should know who is supposed to access that. So access is another critical aspect. Access control, how do you manage in terms of who should access it? Then how you deal with your end of life data, what you will do once the data is of no use. So what is the retention duration? So you need to take cognizance of your end of life of your data. Then what are you complying with? So what geography you're operating in, if what are the key regulatory and industry standards that you need to comply in terms of data security. Examples are GDPR, and there are multiple other standards we will touch upon in next slides. So first, what you see on the right side, you need to have an understanding basically to start with discovery. What is your critical data? What is your non-critical data? Then you need to classify your data. You get the visibility. You understand what are the technical aspects of protecting your data. Is that you want to use encryption or whatever other technical protection methods. Data loss prevention, then data rights management, access management, identity and access management, and then data retention and destruction. So holistically, data being at the center, this is how a model should look like to address all these things for an organization to ensure that they are going to secure their data. So moving on. Now, everybody thinks, so I'm a little bit diving deeper into the technological aspects of how do we protect the data. So what is the best way to protect your sensitive data? Once you know that this is my critical data that I want to protect, what is the best way? So first thing that pops up in our mind is encryption. But is it the only way? So let's understand. So encryption is something that everybody knows. What it is, it can apply to both structured and unstructured data. This is a reversible process. Basically, if I encrypt the data, I have an algorithm to also decrypt that. And this is especially used in data in transit. So the data protection 3 aspects that we have seen. So basically, we do this in data in transit. At rest. Yeah. Now, what is the other mode? Tokenization. I think most of you would have heard this. How it is different from encryption. This is used only for structured data. We cannot use tokenization for unstructured data. This is a reversible process. Usually we do this for highly sensitive data like payment processing systems or customer service databases. Then we have masking. I think everybody would have come across when you're using your example. The best example is when you're using your banking links or software. So you will see a lot of things are being masked there. It's again used for structured data. This is a permanent tokenization. So once you mask any data, it's not an algorithm that will help you to reverse. It's not a reversible process, basically. This is a permanent process. This is usually used in your test environments. Then the last one is redaction. So what is redaction? It's used for unstructured data. This is removal of some sensitive data, basically making it moving away from the actual data. Usually for the legacy data, this is used. Now, let's take an example. So what you see here is an original value. So I've taken an example of a credit card number, right? So we have a standard format there for a credit card number that helps us identify that this could be a credit card, right? So what happens if you use an encryption technology? So you use an algorithm, it's totally changed, right? What happens if you use tokenization? This is a tokenized value that you see. It kind of, if you see a little bit of format is preserved, not in totality, but in masking, it is totally preserved. So what you see is not the original value. This is a permanent value, which is tokenized, and this is not the actual value. If you see, there is a difference, but its format is preserved. It's having 16 digit number value, but the actual value is not there, right? Then redacted value. So you would have seen this redacted value. So actual value is replaced with special characters like star there. So these are the various protection techniques that we use. So now why they're so different? Costs. Any technology that we want to use, it definitely costs, right? So we have to balance it out. What is that I require from my organizational perspective, and what is the best cost-effective way that I can do. So these are the few examples I have cited here. So when we think of, again, protecting sensitive data, point to note here is encryption is not the only methodology or a protection technique. We have multiple methodology and technique that we can utilize. We have to do that cost benefit analysis, and based on the requirement, we can choose and pick and apply the best protection technique here. So with this, I move on now. So this is couple of standards I wanted to highlight, majorly from the data security perspective. So we have KMIP. This is nothing but by OASIS open source standard, Key Management Interoperability Protocol. This is an extensible communication protocol, and this enables the key lifecycle management, right from generation, submission, retrieval to deletion. So what you see, OASIS has been working since 2010 to enhance the KMIP standard, and 2009, the latest is version 2. And this technical committee, this protocol has helped to manage the entire life cycle, right from key generation. So keys are very, very critical and crucial when we talk in terms of encryption that we want to use, any protection technique that we want to use. So right from activating, locating, checking, and getting to deletion of the keys, then key retrieving, revoking, archiving, and recovering, and then key generation. Sometimes you want to rekey it, you want to recertify something. So we have certification authorities, a lot of certification authorities. So these are the protocols that helps everyone to manage the entire life cycle. So this is one standard. Now, how this helps? So it helps to basically standardize, and it eases out for all the servers to support the growing number of encryption clients. So what you see on the left side, this is a cryptographic system. So within an organization, there could be multiple key management systems, which again increases the complexity. Every key management system will have their own proprietary protocol. They will have their own lifecycle management of the key, so which is very, very difficult. So when you use a interoperability protocol, KMIP, the system becomes easier. You have one central enterprise key management. You have through the key KMIP, it's a kind of a language which helps the organization to talk between multiple key management systems. So there is one single key management, and it eases out the complexity of managing the entire life cycle. And also considering the data is always growing with a growing number of encryption clients, it helps doing that. So that is the importance of this protocol. Now, moving on to some standards. So what tips? It's nothing but Federal Information Processing Standard. So we, whenever you deal in certain geographies, there are standards that you need to use. So I picked this specifically from US geography. So let's understand a bit more about these standards. Who are behind this? It's a cryptographic module validation program, which was established by NIST and CSE in 1995. This oversees the validation testing of all the cryptographic modules and algorithms, and It manages the National Voluntary Accreditation Program, that is for accredited testing laboratory. It issues validation certificates and maintains a list of validated modules and algorithm. Now, with this brief understanding of FIPS, it's a standard for data security. Who requires to adhere to FIPS? We should know that, right? So all US federal agencies, Department of Defense, DoD, financial institutions, postal authorities, adapted by the Canadian and UK governments. So the standard is generally, it is established by US NIST. However, this is also adapted by Canada and UK governments there. It's private sector are encouraged, but it's not mandatory. So we do have a standard. So what is this standard helps us? So it defines 4 levels of security: level 1, level 2, level 3, and level 4. Basically, the security increases. So especially when we are working with the public or government sectors, there are certain standards that they mandate that you should be FIPS level 2 compliant, FIPS level 3 compliant. So these levels, in detail, you can go and do, you go through the publication 142, FIPS 142. It helps you to understand what each of these levels of security mandates. Basically, the security increases with the level. So level 1 kind of low, level 2 kind of moderate, level 3 high, level 4 kind of critical, that way. Okay, so now that we have understood the data security aspects, we have understood the data-centric model, we have understood the protection technologies that we can use. Now let's deep dive a little bit more in terms of considerations that we need to keep in mind when we are, because organizations are constantly moving on clouds with multiple cloud providers, so it becomes a multi-cloud. So what is that consideration we should keep in mind? So cloud service model consideration. So when every nature of cloud that you are consuming, if it is infrastructure as a service, we need to identify the data types that we're going to store on that cloud, utilizing that infrastructure. Then virtual disk encryption adequacy, and database and file level encryption. So these are the aspects that we should check when we are moving on to IaaS model of cloud. If it is a platform as a service, we need to validate at the OS level encryption, check for DB level protection options. If it is software as a service, then application level, and also need to check CSP's data protection options. What are the options it is having? Now, irrespective of what is the model, service model of the cloud, we need to keep certain aspects in terms of key management. Because if we are using any of the protection technology, there is definitely going to be keys that we will have. So always go for centralized management. Look for the interoperability across multiple CSPs, because you will have different cloud providers. So if you are using their native key management feature, you need to see how it can apply to the entire organization, because one of the business unit is using, say, Azure, and you're using Azure's native key encryption, and somebody's using AWS. Are they interoperable? So we should have that consideration in mind. Then understand if the organization is operating out of US, Canada, and UK, especially public and government sector, you need to understand FIPS 142 compliance level requirement if the CSP is providing in their native features or not. And then there are also hardware key management systems available. So these are the few considerations you should always think from data security perspective when you are moving on the cloud. So I think with this, we are getting into the best practices for multi-cloud now. Most important aspect is get visibility of your multi-cloud environment. Till now, we were talking about getting visibility of your data, getting visibility of your data centers, where it is stored and all. Now you should have visibility of your multi-cloud environment. How many different cloud providers, service providers, services is your organization or enterprise using? So that visibility you should have. So we have multiple technologies called CASBs, because one is normal IT and there is shadow IT, which is not captured. So it gives visibility, end-to-end visibility to that. Then understand the shared responsibility. So data security is not always one individual responsibility. Definitely it's customer responsibility at the core. However, it is a shared responsibility. If we are consuming any of the clouds, cloud service provider also has their share of data security responsibilities. That clear understanding is required. Now, develop data-centric approach for security solutions. So traditionally, we think security at the enterprise level from information perspective. Now we have to think more from the data-centric approach. How do we want to secure our solutions? Whatever solution we are building in the enterprise, we should have a data-centric approach for that. Now, build data governance policies for multi-cloud. Now, when we are consuming multiple cloud, we need to think from the strategic level, or all the policies that at the enterprise or the organization level available. Is it catering for the governance in this multi-cloud? So we should, if not, we should have our policies built around consideration of multi-clouds. Awareness and continuous monitoring. So just acquiring and building a technology to protect is not the end, because continuous sustainment is what is at most important. So always we have to have continuous monitoring and be aware of the environment and the data that we want to secure. Last but not the least, data security is a process and not a product. So the thinking that I get a product and a protection technology in place is going to secure my data has a flaw. It's a continuous process. It is combination of people, process, and technology. That is what we have to keep in mind when we're thinking about securing data in multi-cloud. So I think with this, I'm done with my session. Here are a few references that will help you to dive into all the aspects that we touched upon in today's session. And with this, I open the forum for any questions anyone has.
Hi, Preeti. Let me just check if there are any questions in the chat box.
Okay.
Preeti, we don't see any questions in the chat box. Do you have an email address where people can reach you if they have any questions?
Yeah, so you want me to tell now, or I think you also have my email ID. Same.
Okay.
It's
so I can
prbisik at in.ibm.com.
Sure. So I'll post in the chat box. It was
Sure.
really a wonderful session. What I'm going to do is I'm going to share the link with you as well of the session. And
Okay. Yeah, so I'm not sure how people would have consumed. So do we get to know if somebody has attended the session in terms how many and all those numbers?
So what people do is, now these are all live sessions. These will be recorded on YouTube, and people keep taking a look at it at their convenience as well. There are few people who were live, and now there are people who are going to come and check that, and they'll post questions, or they'll reach out to you, or they'll reach out to me, and then I'll pass it on to you.
Okay, great. So thank you once again, Vandana. I am glad that I was able to collaborate with InfoSec Girls community now. So yeah, this is great. And hopefully the session that I conducted was of some use and was able to throw some light on the data security aspects in multi-cloud.
Yeah, absolutely, Preeti. It was a really wonderful session. Looking forward to many more collaborations, and within IBM, we'll keep rocking.
Yeah, definitely.